Hi you guys, so this is going to be a video going over the PowerPoint that's titled Tuesday the 19th. We did this on Tuesday and on Thursday of this past week. It's titled Circles. I'm going to be going over a few things regarding that, but hopefully after this video you will feel confident in being able to complete that assignment. I'm going to first cover some circle basics, so just going over some key components of a circle. And then I'm going to move over to the area and the circumference of a circle. From there, we'll go to word problems, and then we'll end up at arc length. And this follows the order of the PowerPoint that we did in class. So in class, like the last thing we did was arc length. First thing we did was this. But all that to say is because this is going to be a pretty long video, so feel free to skip to where you need to. You don't have to watch the whole thing. Same thing with writing it down. Don't feel like you have to write everything down, but definitely write down what you feel is important. Feel free to pause the video when you need to catch up, to rewind, all that good stuff. Okay, so let's go over some properties of circles. So every circle has a center, which is just a dot in the center of the circle. So kind of estimating, I would say that that center is right about there. And every circle has a center. And what's special about the center is that the distance from this center to any part of the circle will always be the same if it's the true center. So that means that line I just drew is the same length as this dotted line I'm drawing. And these lines are called the radius. So the radius is any line that goes from the center of the circle to the outside. And every circle only has one radius, meaning all of these are the same value. Okay, circles also have what is known as a diameter. That's a D. And a diameter is a line that goes through the center but goes all the way to the end. So all the way through the center like that. So notice if a radius is 1 from the center to the outside, if we put two radii together, we get the entire diameter. Okay, let me relabel this real quick. So I'm going to do the radius, labeling this as R. From the center to the outside. The diameter is all the way across. I'm going to label that D. Okay. Then we talk about finding the area and the circumference of circles. So the area is the space inside of a circle. So if we have a circle here, all of this space inside would be considered the area. The circumference is the outside portion of the circle. So imagine we just trace the outside line of the circle. It's like this actual black line. That's the circumference. Think of a pizza. If you have a pizza in front of you, the crust will be the circumference, and the good cheesy pepperoni part would be the area. The inside's the area, the outside is the circumference. So we have formulas for both of those on how to find the area and the circumference of a circle. And if you're on slide 5, or if you look on slide 5 of the PowerPoint, I'll use that example in just a second, but you'll see those formulas there. So how to find the area of a circle? The area of a circle is equal to pi times the radius, and we square it. And I'll show you how we do that math right now. But that's the formula for the area of the circle. It's always, always, always pi r squared. The circumference formula is 2 pi multiplied by r. And these two formulas are something that you eventually would want to memorize. I would say for this class, being able to use them is good. And then we'll work on memorizing. I'll kind of see how the class is doing in terms of the memorization. I might provide it for you on the test. Okay, so looking at slide 5, there's a circle. I'm going to borrow this circle here. And it says that from here to the center to the outside is 5. 5 inches to be specific, but I'm just going to use 5 for now. So you want to first decide, okay, what is that 5? Is it a radius or is it a diameter? And that 5 is a radius because it's only halfway. Remember, diameter is all the way through. So I can say radius equals 5 or r equals 5. Now I'm going to use that in each of these equations to find the area and then the circumference. Let's do the area first. So my area formula is pi times r squared. And this is just a formula that is given. So for the specific circle that's on slide 5, I would say the area, I'm going to do just A for area, is equal to, I don't do anything to pi yet, and I'm just going to replace the r with what this radius was, which was 5. So 5 to the second power. So notice I have area is equal to pi r squared, but instead of the r, it's 5 squared. Then I'm going to actually do 5 squared. So remember, 5 squared is 5 times 5, which is 25. Bring down the pi, and area equals pi times 25. Technically, we can just write that as 25 pi. Think of the pi as like a variable. As if it were like x25, we would write it as 25x. And then that's it. That is the area of the circle. It is 25 pi. Okay, let's do the circumference. So using the circumference formula, I have equals 2 pi times r. And then go ahead and replace the r with what we said our radius was. So we want to replace it with that 5. So then I have c equals 2 pi times 5. Then from here, you multiply the two numbers together, 2 times 5. 2 times 5 is 10, bring down the pi, and that's your circumference. You stop. So you can stop once you get to like one number pi, one number pi. And we have two different areas. We have two different answers, I'm sorry. We have the area and the circumference. So of that circle that's drawn there on slide 5, we have this circle. It was 5 inches from the center here. I know this is ugly, but bear with me. So what you just found out was that the area was 25 pi, or this entire inside was 25 pi. Now I know that doesn't make too much conceptual sense because like what the heck is pi? But that's like an acceptable answer. And then the circumference, you found that the outside, or this black line here, is 10 pi. So that's what each of these problems will want you to do, or for the next 3 slides. You're going to be given one circle and asked to find the area and then the circumference. So two different things. And you would want to use these formulas we have here. So definitely copy these down. Try to memorize them if you can. If you feel confident to try slide 6 on your own, totally try slide 6. I'm going to go over it, so just pause the video and then press play when you're ready to go over it together. Okay, our next practice with area and circumference will be on slide 6. So we're given another circle. This time, notice we're given 3, and since this goes from the center to the outside, 3 is that radius. So right away off to the side, I can say that r equals 3. And I want to find the area and then the circumference of this circle. So I'm getting two different answers here because I'm finding two different things. And you can start with wherever. I'm going to start with the area. So use that area formula. Area is equal to pi r squared. And if you'd like, go ahead and pause the video and see if you plug in r, what you get as your final answer. Okay, and then plugging in that r, we have pi. Instead of r, we're going to put a 3 squared. And then 3 to the second power is 3 times 3, which is 9. So the area is 9 pi. Remember, we put the pi in the back. And we can leave pi in our final answer. That is totally fine. So our area of this circle here with a radius of 3 is 9 pi. So then we do want to find the circumference. So the circumference is equal to 2 pi times the radius. Again, these two formulas, those are the area and the circumference formulas. So definitely have those written down somewhere. And then just like before, we're going to replace that r with our radius. And we don't replace anything else. We're never going to replace the constant 2. We're never going to replace pi. It's always going to be the radius. In this case, the radius of our circle was 3. Then I multiply 2 times 3 to get 6, and I bring the pi. So of that circle, the area was 9 pi, and the circumference was 6 pi. In class, I talked a little bit about the units, meaning this centimeter here. In an area, it's always going to be that same unit to the second power, whereas circumference, it's just that unit once. If the unit aspect is not necessarily the most important part for the test, I will definitely accept it like this. This is just a little bit of an FYI. Okay, moving on to the word problems on slide 7. So this is slide 7, word problem. So slide 7 has a problem that says, imagine we're building a circular stone path. So I'm going to go ahead and just draw a circle. We know that the circle is going to be 4 feet wide in total. And I'm just going to write that down. 4 feet wide in total. If you're like, where are you getting this information? It's from slide 7. Please read the actual situation. I'm just kind of writing down some stuff. Use the area of the circle to help determine how much stone we will need to fill the circle. So we want to find the area of this imaginary circle in the word problem. So we're building a circular stone path, and we know that the circle is 4 feet wide in total. So the total width, so from end to end of the circle, is 4 feet. So that purple line I just drew is 4 feet. Then it says use the area. So I'm going to write the area formula again. The area was pi times r squared. So if I wanted to find the area of this circle, I would replace r with what the radius of this circle is. However, that purple line is not the radius. That purple line is the diameter. So I would say that the diameter equals 4. Remember, the radius is only halfway from the center to the outside, like this blue line I'm drawing. So the radius would be half of that full purple line, so that radius would then be 2. Then same thing as before, I plug in my radius here. I think you guys can do that, and you will get what the area of that circle is. Let's move on to slide 8, and then as a reminder, feel free to pause this video whenever you need to. I'm just kind of going through the slideshow as I'm going through them, but definitely pause, rewind, do what you got to do. So slide 8, again, please read the situation that is on that slideshow. I'm going to write some of the key components here. It says, now we're building a circular jacuzzi. The jacuzzi is going to be 6 feet wide all around, 6 feet wide. We want to line the outside of the jacuzzi with stone panels, determine how long the outside of the jacuzzi is so that we know how much stone to get. So rereading this back, I definitely can see where a lot of the confusion came from because that problem is very confusing. One of the things that initially confused me right now as I was reading it back was the sentence that said the jacuzzi is 6 feet wide all around. That makes it seem like that around it's 6 feet here. That's not what that sentence is saying. What that's saying actually is that, It's 6 feet wide. Imagine you're standing in the jacuzzi and you're trying to like wrap your arms or stretch out your arms. That's how wide the jacuzzi is. So this blue line here, that is 6 feet. And then again, is that 6-foot line the diameter or radius? Go ahead and see if you can correctly label that. And it is the diameter because it goes all the way across. So even though the problem doesn't tell us what the radius is always half of the diameter. So whatever half of 6 is, which is 3. Remember, half is the same thing as dividing by 2. Oops. And you can write that little note to yourself as well if you'd like. You can put it at the top of the notes that the radius is always half of the diameter. And I know this is sloppy, my bad. Okay, but the radius will always be half of the diameter. That diameter is 6 feet because it said the jacuzzi was 6 feet wide. And so the radius is half of that, which is 3. Okay, so then it says we want to line the outside of the jacuzzi with some stone panels. So imagine we are lining the outside of this jacuzzi here, what I'm highlighting in yellow. Imagine we're lining this with like some stone panels. Determine how long the outside of the jacuzzi is. So we want to determine like what is this length here, this yellow highlighted stone path. So notice we did talk about what the area and the circumference were. So going back up, remember the circumference was the outside portion of the circle. So of that jacuzzi problem, we want to find the length of the outside or how much stone we'll need. So we want to find the circumference. So we use the circumference formula. We use the circumference, I'm going to abbreviate it, formula, because we want the length of the outside. The length of the perimeter of the circle, of the perimeter, that's the same thing as the outside. Again, don't feel obligated to write all of these notes, but this is just, I know sometimes it is helpful to have notes to look back on. And again, pause it if you need to because I just start rambling. But we are using the circumference formula because this problem says determine how long the outside of the jacuzzi is. So we want to know how long is this? Like if we were to take a circular measuring tape and measure our jacuzzi, what is it? Well, we don't have a measuring tape, so we have to use the circumference formula because the circumference is the outside of a circle. So our circumference formula is 2 pi r. Go ahead and again, see if you can plug in the correct value. So for the r, careful not to plug in that 6 because 6 is the diameter. So it should be 2 pi 3. And then you get the final circumference of 6 pi. That 6 comes from 2 multiplied by 3. And since this is more of a real life situation where we're talking about an actual jacuzzi, we can multiply instead of pi. Let's do 3.14. So we're going to find the actual length. Remember I said imagine we had like a measuring tape. We're going to find that actual value by doing 6 multiplied by 3.14, which is 18.84. And we were talking about feet in the problem. So basically what we figured out, I know it's kind of a lot. Let me get rid of all of this mess. We had a jacuzzi. And the jacuzzi was 6 feet wide, which meant that the radius of that jacuzzi, or from the center to the outside, was half of that, which is only 3. And this problem says determine how long the outside of the jacuzzi is. So how long is this circle essentially? We just determined that that circle is about 18.84 feet, or about 19 feet long. Now it doesn't look 19 feet long because it's a circle, but if we were to like open it up and stretch it out, it would be about an 18.84 foot circle. Okay, the last thing we're going to talk about is arc length, and this has another formula for us, so I know it's a lot of formulas. If you feel like your stressor is not memorizing the formulas, that's okay. Like, as long as you know how to use the formulas, that's what's important. So this arc length formula, and I'll explain what an arc length is as we get started, but it's going to be that the arc is equal to the angle multiplied by the radius. Okay, so write this down somewhere next to your area and your circumference. We're going to have this one. Now, how I have this abbreviated in the notes is I have the arc still, arc equals, and instead of writing the word angle, I put this little symbol that means angle. So if you see that symbol in the note, it just means angle. And then instead of writing the word radius, I have that R there. So definitely get used to seeing this as an abbreviation for the word angle. It's technically called a theta. It's just used a lot in math to represent angles. Okay, so then we have a circle, and I'm sorry, this is on slide 12, if I did not specify, slide 12. I skipped over some of the beginning slides talking about arc length. It was just kind of notes and stuff. So we are given an angle on slide 12. I'm just copying it down. Looks something like that. Goes from A to B. And notice it says this angle is pi over 3. Now you might be like, that does not sound like an angle. That's an angle in a radian, which is totally fine. It's still an angle. And then it shows that from here to here is 2. Okay, I did get this circle from slide 12, so I did not just completely make it up. So an arc of a circle is like the piece of the circle that gets created by an angle. So if we have an angle here, this blue angle I'm tracing over, the arc that gets created is this portion of the circle here that I'm highlighting in blue. That's the arc. And we can find that length using the arc length formula. So I could say the arc, and sometimes we'll name it, like we'll name it AB, but we don't have to if we don't want to. That arc is equal to, and I'm following this, the angle. So the angle is right here, the pi over 3. So the arc is equal to pi over 3 multiplied by the radius, which was 2. From the center to the outside is 2. So this information, hold on, I'll highlight it in a second. The angle and the radius, that was provided on the circle. Like the circle shows that. The circle shows that pi over 3 is the angle and that 2 is the radius. We just have to put those values into the formula and find what is the arc length, which is this piece of the circle here. So then I'm just going to rewrite this down here, that the arc is equal to pi over 3 times 2. A common mistake I'll see is that students will try to multiply 2 to both of these numbers. We do not want to do that. Pi over 3 is a fraction, and technically 2, the fraction version of 2 would be 2 over 1. So now I multiply fractions, numerator with numerator, denominator with denominator. On my numerator, pi times 2, I can actually just write as 2 pi. And on my denominator, 3 times 1 is 3. So the arc is equal to 2 pi over 3. And that's my final answer. My answer has pi in it. That's totally fine. Okay, if you feel comfortable, go ahead and pause the video and try the the problem on slide 13. And then when you're ready to see the answer, or if you get stuck, just press play. I'll do slide 13 with you guys, and then I'm not going to do 14 or 15. Okay, so slide 13. We got a circle again. Whoops, not nice. Another angle here. So this angle is a little bit bigger. Again, I'm drawing this by hand, so if it comes a little sloppy, my bad. But it is on slide 13. This is a Y. And we have from here to here. So this little loop will typically show us like what's the angle. From one leg to the other, it's 2 pi over 3. Again, that's not in degrees, it's in radians, but that's okay. And on that same picture, we're shown that from the center, that this line here, from the center to Y, is 4. And so we want to find, or we're being asked to find, the arc x, y. So you'll see x, and you'll see y. The arc, remember, it's where the angle, so this is my angle here. If it were to cut the circle almost, the arc is this portion of the circle. So I want to find that value. So I do have my arc formula. Again, write this down if you do not have it. The arc is equal to the angle times the radius. And then you just plug in your values. So if you want, go ahead and try this on your own. Plug in the angle. What's the angle? And plug in the radius. What is that radius? You can say that the arc is equal to, the angle is this angle here, 2 pi over 3. And the radius is 4. And notice we're not cutting this in half like we were the diameter a few problems ago, because it only goes halfway of the circle, center to the outside. We don't have to cut it in half. It's already halved. Okay, and then we multiply these fractions. Again, I'm just going to write them down here. Arc is equal to 2 pi over 3 times 4. Again, careful not to multiply 4 to both numbers. You've got to put it over 1. Then multiply numerator with numerator, denominator with denominator. 2 pi times 4 becomes 8 pi, and 3 times 1 becomes 3. So the arc is equal to 8 pi over 3. Hopefully this video helped. If it didn't, honestly, be honest with me, I can take it. Sometimes I can hear myself being confusing, so honestly, I can just let me know if it helped or not. Feel free to please try slide 14 on your own. Slide 15 is a bit of a challenge question, but it's also a little bit poorly written on my part, so don't feel obligated to do 15 at all. But I do encourage you guys to all try slide 14, and then turn in the assignment as soon as you're done with it, please. Thank you.